So I'd like to wish everyone a happy March 19th. One might think that there's only 2.5 more days of school that you'll have in the month of March at James A. Garfield, but you would be mistaken to think that. So anyway, we're looking at Chapter 5, Section 2. We're talking about polynomials, linear factors, and zeros. So if I'm taking notes, what I would write, 5.2, polynomials, linear factors, and zeros. So there's going to be a quiz on Friday over this material. There's something that's really not mentioned here, but we will look at it. It will be on the quiz. I'm not sure how I'll handle that, but you didn't have to do it in Math Excel, but we'll get to that in a minute. So, okay, first thing I want to say then is this. This is called the factor theorem. The factor theorem. It's real important, super important. Anytime I write something on the board, usually it means, well, it's good to know. It says if A is a 0, then the quantity x minus a, is a factor. Okay. That idea, we've seen it in Chapter 4, and we're going to see it again in Chapter 5 over and over and over and over and over again. Again, it says if a, some number a, we don't know what a is, it's a real number. Could be imaginary too. But if a is a 0, then x minus a is a factor. So what they're going to ask you to do then is they're going to say, write a polynomial of least degree, with zeros of 2, -2, and 7. They're going to ask you to do that. Write a polynomial of least degree that has zeros of 2, -2, and 7. What would the degree have to be since there are 3 zeros? What's the smallest degree that this would have to be? There's 3 zeros, so the degree would have to be 3. Good. Okay. So if we had to do this, then what we would write, we would say, okay, so the polynomial, we don't know what it is, we'll call it p of x. It equals something. So we look at what the first given 0 is. The first given 0 here is 2. Because of that 2, we know that one of the factors of this polynomial is, having trouble with my pens today. One of the factors is what? Anyone? One of the factors. It's not going to be just a number in there. It's going to have some a variable with it too. X minus 2, nice. Because 2 is a 0, x minus 2 is a factor. Okay? This idea is going to come up time and time again. It's going to come up in 5.4. It's going to come up in 5.5. It's going to come up in 5.6. It's going to happen the rest of the time through the chapter. So it's real important that you get these ideas. Okay? Because negative 2 is also a 0, that tells us that something else is a factor. What's a factor? Nice, x plus 2. Now we could have written that as x minus minus 2, but it simplifies to x plus 2. Okay? We're doing all right so far. Okay? Finally on the end then, if we look at that last item up for bids, the 7, because 7 is a 0, that means what else is a factor? X minus 7, good. Okay? Everybody doing okay so far? Now, in Math Excel, or even on a test or a quiz, whoever they are, they might say, well, you know what, that's not good enough. Let's put this in standard form. So you know what that means, right? I got skills in multiplying. And I'm losing control. Okay, I'm going to go ahead and FOIL these first two factors. Normally I multiply in a different order, but I'm going to multiply those two first because I like what happens. Anybody know what happens when you do the EO part of FOIL? What happens when you do the EO part of FOIL? You get minus 2x plus 2x. What happens? They cancel out. So we're going to get x squared minus 2x plus 2x. That cancels out. So x squared what? Minus 4. Good. And then we still have this factor of x minus 7. Everybody doing okay so far? Now we're going to FOIL again. So x squared times x is x cubed. The outer product gives me minus 7x squared. The inner product gives me minus 4x. And then the last term is plus 28. So before we move on, I'd like to analyze this, if I could, for a second. How do I get the x squared minus 4? That's a good question. I have a feeling I messed something up on this. The x squared minus 4 comes from, let's see here, comes from foiling the x minus 2 and the x plus 2. When I FOIL this right here, I'm going to get x squared plus 2x minus 2x minus 4. And the 2x is cancel. Okay. Oh, yeah, good question. Would that have ended up the same if it was in any order? So let's look at that. Let's look at P of x is x minus 7 times x plus 2 times x minus 2. So if we FOILed this, we'd get x squared minus 7x plus 2x minus 14, that quantity times x minus 2. So we'd get x squared minus 5x minus 14 times x minus 2. Here's a skill that you might have done in Algebra 1. Check out how this goes. A couple different ways to do this, but I'm going to go ahead and distribute this to all three of those. Okay. So when I do that, I'm going to get x cubed minus 5x squared minus 14x. Everybody see what I got going on there? Now watch what happens when I distribute this next one. When I distribute this next one to all three, I'm going to put my terms in a little different spot. Negative 2 times x squared is negative 2x squared. Negative 2 times negative 5x gives me plus 10x. And then negative 2 times negative 14 gives me plus 28. Do you see why I wrote those terms where I wrote those terms? They line up real nice. And so when we go to combine our like terms, let's see what we get. X cubed minus 7x squared minus 4x plus 28. Let's do a split screen and see how we did. Did we get the same answer? We did. The commutative property of multiplication. Okay. Are there any questions, comments, concerns, short debates about what we've seen so far? Going once. Going twice. Sold to the lady in the third row. That's not how the song goes. How does the song go? Sold to the lady in the... Okay. All right. Oh, problem 1. Hey, we saw ones just like this in the Math Excel homework. It says, what's the factored form of this? As I graded and made corrections to the Chapter 4 tests, I noticed that some of you are not quite grasping the idea of factoring. And what I mean by that is I think you know how to factor, but you don't understand what factored form means. Factored form, what this really is implying, the hidden message here is all the factors must be shown. Okay? Now, it's true you can factor out a GCF out of this. And on the test, what some of you would do then is just say, well, the answer is x because x is the GCF. Well, that's one of the factors, okay? But that's not what we're after here. They want factored form. In other words, all the factors must be shown. Well, x, I said x, oh, it's going to be one of those days. X is the GCF, okay? There's more to it than that, but that is the GCF. So we're going to factor that out, and when we do, it's going to leave some stuff in its wake. It's going to leave behind x squared minus 2x minus 15, okay? Notice we have two factors. We have the GCF and the other stuff too that's left. Everybody understand what I'm saying, I hope? Okay. So it says, what's factored form of this? Well, hopefully, from chapter 4, you recognize that the trinomial factors further into an x and a 3 and a 5, and a minus on the 5 and a plus on the 3. And if you don't get that, at this point in time, I hate to sound cruel and unusual and mean, but if you don't get that, you're really going to be struggling the rest of the chapter, because you're going to have to know how to factor moving through the whole rest of the chapter. So if you don't get that now, see me third period, see me after school, stop in on a Tuesday, whatever, but you really need to be able to factor that quick. Okay? Questions, comments, concerns, short debates about that one? So as I was doing these in Math Excel, if I look at this got it example, some of you want to jump straight to the final answer. As good as I am at factoring, I have a hard time jumping straight to the final answer, okay? I strongly urge you on something like this, write down the intermediate step. Get a piece of paper. Remember a couple weeks ago, I spent 2 or 3 days in class talking about well, I think it was just one day. But anyway, all the stuff you should be doing, right? Get out a sheet of paper and write this down. X times x squared minus x minus 12, okay? Before you go to Math Excel and try to enter this, x times x minus 4 and x plus 3. Okay. Are there any questions about either of those two problems there? The one thing that I'm glad that I've seen is most people who've done 5.2 are already done with it. So that tells me either you're pretty good at factoring or, well, I don't know. I don't know what it tells me, but keep in mind, when you factor it, all the factors must be shown. Okay. All right. Moving right along then. What they're telling you in this key concept box is basically what I had already said. So let's go ahead and look at this problem 2. It's kind of taking that factor theorem and working the other way. Problem 2 says, okay, hotshot, what are the zeros of this function? So if we look at this first factor here, what is a zero that we get from that? What do we got? -2, nice, good. So because of that, we see that -2 is a zero. What that means is on the graph, when we graph this, the graph will go through the point -2, 0. The graph will go through -2, 0. Remember, a 0 is the same thing as an x-intercept. It's the value of x whenever y equals 0. Okay. All right, well, let's look at the next one. Because x minus 1 is a factor, what's another 0? 1. Good. 1 is a 0, so on the graph we go to the point 1, 0, and the graph's going to go through there. And I think by now we probably get the idea, because x minus 3 is a factor, 3 is a 0, and the graph's going to go through the point 3, 0. Okay. Are there any questions about that? Now what they're saying is, okay, hot stuff, graph it. Well, we've got the zeros plotted. Something else we might be able to find is the end behavior. The end behavior is going to be a result of multiplying all of the first terms. X times x times x. I'm not going to FOIL this out, okay? It's going to take a significant amount of time, more time than I want to spend, and I'm not going to FOIL this out. But what I am going to do is find out what my leading term would be. My leading term, the result of all that, my leading term, if I were to multiply x by x by x, would be what? Anyone? X cubed. Nice, good. So my leading term is x cubed. So let's think back to the last section. The coefficient of that is positive 1, which means what happens on the right side of the graph? It goes, on the right side of the graph, it goes up. Good. So on the right side of this graph, the graph is going to be heading upward. How far, how fast? Who knows, but it is going to be heading upward on the right side of the graph. Everybody see that? Okay. Now, because the degree is odd, because, let me get my magic marker going here. Because the degree is odd, that means the graph acts like a line. What we mean when we say it acts like a line is on the other end, it's going to go down. Doing all right so far? Okay. So it's going to be heading down on the other side then. So like that. And as far as in the middle, what happens? Well, we can see that it's got x-intercept, so we could speculate and we could maybe sketch this kind of stuff in if we, well, I can't do that. So I got to wait for that to fade away. 5 seconds. 4, 3, 2, 1. There it goes. So it's probably going to go up like this and then come back down like this and then go back up like that. Somehow, right? There is one more point that we can get pretty easily. Not a whole lot of people think of this one. I do. I'm going to multiply 2 by -1 by -3. The product of that's going to give me my constant. Okay, the product of all that is going to give me my constant. So what's 2 times -1 times -3 going to give me? 6. What did we say the constant also was? Think back to 5.1. What did we say that is? It's part of the graph. Thank you, good. It's the y-intercept. That's our y-intercept. Okay, so when we go to graph this, then our y-intercept is 6. 1, 2, 3, 4, 5, 6. That's our y-intercept, 0, 6. So that gives us a little bit more help in determining what exactly is going on in the middle, right? And that's it. If you're asked to graph one of these, the end behavior, the zeros, the y-intercept. Other than that, I could care less. If you just plotted those points, that'd be good enough for me. I'd be happy with that. Questions, comments, concerns, short debates about that. So real quick then, while I've got my TI Inspire up and at 'em, I'll go ahead and graph that. So I'll go to a graph page. And the function was the group of x plus 2. I said 2, not 22. Times the group of, was it plus 2? And then -1 and -3. X minus 1, and then x minus 3. So we graph that, and that's what the graph looks like. See if I can take a picture of that. So when we look at the graph, one thing we should notice on the graph, even though it's kind of covering what we graphed a second ago, we should notice again it's got zeros at -2, 0 at 1, and a 0 at 3. Everybody doing all right with this? Easy peasy? Okay. Well, before we move on any further, I want to take just a second and talk about a local. A local. If we think about the word local, and you're at James A. Garfield High School, you think, oh, those darn rednecks from Nelson. Not everybody in Nelson's a redneck, so that's a pretty racist statement to make. All those people from Wyndham, those transfers, those students that live out of the district and drive here, they're not local. The locals are everybody who wears camo and boots and drives a truck with a big diesel stack. That's not the kind of local we're talking about, okay? So what's happening in this last graph, the graph does something like this, and it does something like this, and it does something like this. When I refer to the word local, talking about a polynomial, what I'm talking about is this thing here and this thing here. And we're going to throw a couple more words in addition to local. We're going to say relative. Oh, now he's talking about West Virginia. Thanks a lot, Mr. Minnick. First you insult Nelson, and now you insult West Virginia. Relative, local. Let me get a different color highlighter for each one of these. Relative, local, max, and min. Relative local max and a relative local min. So one of these is a max and one of them's a min. I guess this one's a max, and the min would be this one. Okay. It's not a maximum of the function and it's not a minimum of the function, but it's a local max and it's a local min. Okay. Does that idea make a little bit of sense? Okay, good. On the quiz on tomorrow, on Friday, you will be asked to find those. Now, the quiz is going to be on Friday. So that occurs at a point. So when you find one of these, you should have two coordinates. You should have a set of parentheses and an x coordinate and a y coordinate for each one of those. Okay? Everybody doing all right so far? So in a few minutes, we're going to be doing this on the calculator. So you might want to grab a calculator at this point while we kind of come back and look at this last graph. So we'll come back to that one in a minute, and we will find the local mins and the local maxes and go over how to do that. So while we're taking a slight intermission for calculator time, I'm going to give shout outs. I'll give a shout out to the future Mr. Minnick. I'm going to give a shout out to Logan Steiner for wrecking Parker Ricky freshman year in the Wyndham game. I'm going to give a shout out to Mason. Nate loves you. I'm going to give a shout out to Brian Reagan. He's going to be the next president of the United States. Oh, he's going to be in the talent show too. He's going to shred it. He's going to melt your faces with a guitar solo. Shout out to my 5th period class. What's up? Okay. So before we get to the calculator, I got to look at this got it. I saw this got it and I said, you know, I want to skip this, but I don't. There's 1 0 on here. Calculus students, pre-calculus students, algebra 2 students, advanced algebra 2 students, the best students on the planet, intermediate students, and the worst students on the planet. It always screws everybody up. I don't understand why. I never understood why it screws people up. Maybe you can help me figure it out. But that factor right there, it tells us about a 0. It tells us what is a 0. Somebody said 1. It's not 1. Thank you. 0 is a 0. 0 is a 0. The person who said that said he was joking. Well, it's true. 0 is a 0. That really can be rewritten as x minus 0, which means that 0 is a 0. 0 is a 0. Don't ever forget that, okay? So 0 is a 0. Because of this, we know that 3 is a 0. And then because of this other one over here, we know that negative 1, 2, 3, 4, 5, negative 5 is a 0 also. Okay, the end behavior of this graph would be down and up. The y-intercept is also 0 because we would have, and I know you're thinking, well, it's negative 3 times 5, but then that other factor is x minus 0. So negative 3 times 5 times 0 would be 0, and so those are the critical points on that graph. Okay, are there any questions about that? Okay, so if you don't have this function in the calculator, let's go ahead and put that in there. You go home. I'm going to start up a new document. You might already have a document. Please don't use the scratch pad. I see people using the scratch pad. Don't use that. If you're in there, hit escape. And you want to actually be in the calculator portion because the scratch pad's limited in what it does. So from a menu screen, I want to add graphs. And I'm going to put that function in factored form. It's fine. So the quantity x plus 2, arrow over. I said arrow over. The quantity x minus 1. And the quantity of x minus 3. Now, are any of you using a TI-83 or 4? I'll bring that calculator up because we'll have to do that on that one too. Both calculators will do the same stuff. It's just a different way of getting there. It's kind of like driving a stick and driving an auto. Speaking of cars, has anyone seen the new Corvette? It's a Corvette. I saw the Corvette. I'm not sure what model, but I saw a new Corvette and I thought I was on a different planet. It was so amazing looking. Never seen anything quite like it. It looked like something out of the movies for real. So here we go. Y equals the quantity of x plus 2 times the quantity x minus 1 times the quantity x minus 3. So all my TI-83 are 4. Again, I put the function in factored form, and then I hit the graph button. Okay. Notice on the TI-83-84, I see a better picture of the window, don't I? Let me do a zoom. I said a zoom 6. On the TI-84, the standard window goes from -10 to 10 on the y-axis. On the Inspire, the y scale only goes from -7 to +7, okay? Or -6 2/3 or whatever, so. Okay, so on the 84, if I want to find the local maximum, it's a little different than doing this on the Inspire. But we can still get there. Let me go ahead and cut that out and put it on a new page. Cut. Paste. Here we go. So what we're after, when we find this local minimum, local maximum, what we're after is that point right there. To find it, we're going to have to find a lower bound and an upper bound. If you don't understand the concepts of bounds yet, stop in and see me sometime. I'm not going to take 7 minutes and explain it. Okay? Lower bounds and upper bounds, they're points on either side of that point. Okay? So I'm going to press second. Let me show you the keystrokes I'm pressing here. I pressed second trace. And I want to find a maximum because it's a local maximum. So second trace, option 4 here. And where my cursor is flashing right now, it's not in a good place to be a lower bound. So I need to move the cursor. And now it's okay. That's my lower bound. Now it says right bound. So I want to move the cursor on the other side of that point. And that's probably good enough. So my lower bound, or I'm sorry, my relative local maximum then occurs at -0.79 and then 8.21. So negative 0.79 comma 2 point whatever that was, 2 point something, 8.2 something, 8.21. Okay. Are there any questions about doing that? So for the other one, then let me find that on the Inspire. Okay. On the Inspire, I'm going to find the minimum. I'm going to go menu. I press menu, and then you got to be careful how you say this. Somebody once told me, a wise person told me, it's not what you say, it's how you say it. We're going to use option 6. We're going to use analyze the graph. And we want to go with the minimum. Okay, the minimum. So again, my calculator's asking me for a lower bound. Well, I'm trying to find the point at the bottom of the graph, the lowest point. So my cursor is not where it needs to be. I'm going to move my cursor over a little bit. I'm going to keep on moving it over. I want it kind of close. And that's probably good. So I'm going to press enter. And then it says upper bound. So I want my cursor on the other side of that minimum point. So I'm moving my cursor over. Notice how it pops up right away. It says, there's your minimum. There it is. There it is. So I'm going to keep on moving the cursor until I know for sure that that's my minimum, and that is for sure my minimum. So then that one's 2.12, negative 4.061. Okay. Are there any questions about that procedure? You will have to do this on Friday's quiz. If you don't know how to do this, between now and Friday, come see me with a calculator you're going to be using, and I'll gladly go over it again. Okay. Questions, comments, concerns, short debates, long debates? If not, hey, there's that factor theorem again. Wow, must be important. What's a cubic polynomial in standard form with these zeros? Hey, we kind of did one just like this. I'm going to skip over part A because we did one just like that. I want to go to part B. Oh, no. Oh, no. That's going to take forever, Mr. Minnick. We can't do that. We can't do that. We can't stop. I shouldn't do that. That's not right. So the polynomial function here, I said the polynomial function here, who can hit me with all the factors? What are we going to have? X plus 2, nice, good. X plus 2, X plus 2 again, X minus 2, and X minus 3. Good. Awesome. Everybody doing all right? Is that in standard form? No, it's not. Oh, no, this is going to take forever. Wow, lots of multiplying, lots of distributing, lots of terms to keep track of. In the end, since it's quartic, we're probably going to have 5 terms. The way I'm going to approach this is this. I'm going to multiply the first 2 binomials and then the last 2 binomials. Okay? So this is going to go kind of fast. This will be up on YouTube, hopefully. So I get x squared plus 2x plus 2x plus 4, which is then going to be x squared plus 4x plus 4. Okay. Out of the first set. And then out of the next set, I'm going to get x squared minus 3x minus 2x plus 6. And when I simplify that, that's going to be x squared minus 5x plus 6. Okay. Now, here's where the fun starts. Be consistent with whatever technique you use at this point. I'm going to go ahead and take this first term here and multiply it by each of those 3, okay? Whatever you do, just be consistent with it, okay? So when I do that, I'm going to get x to the 4th minus 5x cubed plus 6x squared. And after I do that, I would kind of do like a strike through and say, okay, I'm done with that one now. When you're doing these, I strongly recommend have 2 or 3 or 4 colored pencils with you. Maybe have a blue pen and a black pen and a pencil, okay? Many of you know that I use a pen a lot. Whenever I do stuff like this, I'll use a pen and a pencil, and if I can find another colored pen, I'll even do that, okay? It's real easy to lose track of one of these terms along the way. So the next thing I'm going to do then is multiply this 4x by everything. The 4x, I'm going to multiply it by everything, okay? So when I do that, I'm going to get 4x cubed. And then minus 20x squared, minus 20x squared, and then plus 24x, plus 24x. Okay? So now, again, I do a strike through that 4x because I'm done with that. I've multiplied that by everything. Okay? And finally, I'm going to take 4 here and multiply it by everything. So that's going to give me 4x squared. Notice I end up with 3x squared, 3 different terms here with an x squared in them. That happens. So I get 4x squared minus 20x and then plus 24. Okay. I've got a lot of work here. Be ashamed to mess it up at the very end. So I get x to the 4th minus x cubed. 6 minus 20 is negative 14. Negative 14 plus 4, I guess that's negative 10. Minus 10x squared plus 4x plus 24. Woo! Wow. Now, if you think that's difficult, you know what we're going to be doing in the second half of the chapter? Second half of the chapter, we're going to be working backwards from that back to the factors. Believe it or not, it's actually easier to go backwards than it is to go forward in this. Yeah. what I could, there's a bunch of different ways I could have multiplied this. I could have multiplied that together first, and that would have just given me a binomial. Yeah. And I thought about doing that, but I said, well, let's just show one of these just to see how it would be done. There's something else I could do, and I'm almost afraid to show this. I'm almost afraid to do this. You all use the netbook cart, the M cart, the MM cart, whatever it is, right? Who uses the TI-83 emulator that's on there? Anybody? Okay, check this out. By default, when you're using that emulator, it shows up as this TI-83 calculator, right? Well, watch this. I'm going to right-click, and when I right-click, it brings up a little menu. I'm going to click on Set Calculator ROM Version. I'm going to change it to a TI-89, and I'll show you why a TI-89 should be banned in 48 states. Why you're not allowed to use it on the ACT, because I'm going to go F2. I'm going to expand this. I'm going to expand the group of x plus 2 times the group of x plus 2 times the group of x minus 2 times the group of x minus 3. I'm going to expand that. Ah! What do you think of that? We're not impressed. We're not impressed. I'm impressed. I think that's great. I think that's the horse's pajama, the cat's meow, the bee's knees. Any questions, comments, concerns, short debates about that? Okay. Now everybody's going to go out and buy a TI-89. So what we need to talk about next, we got about 10 minutes to do that, is multiplicity. Multiplicity. I'll say this about multiplicity. If a 0 occurs once, its multiplicity is 1. Well, that's pretty sensible. If a 0 occurs once, its multiplicity is 1. Similarly, if a 0 occurs n times, its multiplicity is n. This doesn't make any sense yet, Mr. Minnick. It will in a second. If a 0 occurs once, its multiplicity is 1. If a 0 occurs n times, its multiplicity is n. That one's going to save me a whole lot of writing, because I could have written for 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11 or 12 or 13 or 14 or 15 or 16 or 17 or 18 or not. You can say stop if you want. Or 19 or 20 or 21 or 22 or 23 or 24 or 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Nobody's going to say stop. 35, 36, 37, 38, 39, 40, 41, 42, 43. Okay. All right. Thank you. Okay. So examples tend to clarify things. Here's this really nasty polynomial function, okay? It's going to have all kinds of factors. It's going to have the group of x minus 8, the group squared. It's going to have the group x plus 4, the group cubed. It's going to have x to the 5th, and it's going to have the group x minus 42 to the 7th power. Okay? Wow, that's a lot of factors. You're darn right it is. It's also a lot of zeros. Zeros. The zeros, the roots. Because x minus 8 is a factor, what is the 0 with that factor? What's the 0? Because x minus 8 is a factor, what's the 0? Somebody said it? 8, good. 8 is a 0. Okay? Because x plus 4 is a factor, what is a 0? Negative 4, good. Let's skip to the end one. Because x minus 42 is a factor. What is a 0? 42. Hopefully somebody remembers this one. I hope somebody remembers this one. Because x is a factor, what is a 0? Thank you. 0 is a 0 also. Everybody all right so far? So let's look at their multiplicities then. Let's look at their multiplicities. I said their multiplicities. Not there like that. T-H-E-I-R. Their multiplicity. Their multiply-city. Okay? In other words, the multiplicity of each one of those zeros. The first one is 2. Do we see where that comes from? From the exponent, yeah. So what we're saying here is because of that exponent of 2 on that particular factor is really x minus 8 times x minus 8, which means there's an 8 and an 8 as a 0. And instead of saying the zeros are 8 and 8, we say the 0 is 8, and it has a multiplicity. That 0 has a multiplicity of 2. Does that idea make a little bit of sense now? Good. So let's look at the rest of the multiplicities then. What's the multiplicity of the negative 4 0 then? Anybody? 3. And then of the 0? Of the 0, it's 5. And of the 42, it's 7. Let me throw one more factor on the end. What if we had a x minus 11/2 then? The other 0 would be 11/2. And what's its multiplicity? Just 1. Just 1. Are there any questions about that idea of multiplicity? Pretty easy idea, huh? Question. In Math Excel, there's a function that'll say this. It'll say P of x is 8x cubed minus 8x. They're just like this one. Okay? And it says what are the zeros and what are their multiplicities? Well, what you'd have to do first is factor this. We'll replace this with a 0, and we factor out an 8x, which leaves x squared minus 1. So we get 0 equals 8x times x plus 1 times x minus 1. And this tells us what is a 0. What's a 0? What's a 0? Somebody said it. Say it again. Say it loud. Say it proud. Thank you. 0 is a 0. And this tells us what else is a 0? Negative 1. Good. And then this one tells us what else is a 0? Positive 1. Now let's look at their multiplicities. Their multiplicities. The first one. What's the multiplicity of that 0? 1 because it happens once. What about the next one? 1 because it happens once. What about the next one? 1 because it happens once. So in Math Excel, it's tricky because they give you these dialog boxes. Because each of those factors only occurs once, their multiplicities of all those zeros is 1. So in Math Excel, you'll use the dialog box that says the zeros are and their multiplicities are 1. Does that answer your question? Okay, cool. Good question. I'm glad because this one seemed to be giving some people some difficulty. Okay. Any other questions, comments, concerns? I think I've got one more concept I want to look at. And this, unfortunately, doesn't surface in Math Excel. It really disappoints me that it doesn't. Okay. Well, I want to show you real quick, and you still got the graphing calculators. I want to show you what it means when a 0 is repeated. So if we have a function f of x and it goes like this, x minus 2, the quantity squared. That x minus 2 is a bad choice. Let me go x minus 1, the quantity squared, okay? Also then times x plus 5, okay? Let's first look at this. What's a 0 because of this? What's one of the zeros there? Negative 5, good. So on the graph, it's going to be right about there. Negative 5, 0, okay? Everybody follow me? Because of this other factor, what's another 0? 1, and it happens twice. Its multiplicity is 2. Everybody see that? Watch what happens on the graph with this. The end behavior is going to be down, up. The end behavior is going to be down, up, okay? I want you to watch what happens at the graph right here. Let me just say real quick that the graph here is going to look like a line. If we zoomed in, the graph here is going to look like a line. Everybody see what I'm talking about a little bit? What do you think the graph's going to look like at the other zero? Do you think it's going to look like a line? Let's see what it looks like. So home, new new document, no. Add graph, here we go. So the function, I said add graph. Come on. Somebody said something. It's going to look parabolic there. Yeah, it's going to look like a parabola there. And now my calculator decides to go crazy. Real quick, on this calculator, y equals, so I had x plus 5, and then what was the other one? X minus 1, thank you, the quantity squared. I said the quantity squared. Let's graph it. Look what happens at that 0. The graph looks like a parabola there. Okay, that's a pre-calculus concept that I need you to realize. The fact that the multiplicity is 2 means the graph's going to look parabolic there. It's going to look like a parabola there. If it were a 3, the graph would look like a cubic function there, and we'll talk more about that next week. Okay, it's been real. It's been fun. Any shout-outs, comments, concerns? Tomorrow you'll have the netbooks to finish Math Excel. And then on Friday, we will have an open note 4-question quiz over polynomials.